So we are starting with the very first point in our while example loop. And this is the starting point of the loop where the robot steps have been set to 1. While steps are less than or equals to 3. As long as the steps our robot will take are within the bounds of 3. So notice I use the curly braces, very similar to how I use them with an if condition. Because curly braces means the body. Some people make this mistake on the quiz. When I ask you to fix the mistake in an if block, some of you put a semicolon in the line of the if. You never put a semicolon in the line of a block. So block is anything that has curly braces, and you never put semicolon in a curly brace. Semicolon only goes on a single instruction. Okay, that's why line number 3 is a single instruction. It has a semicolon. But line number 1, line number 2, line number 4, you see curly braces on all 3 of those lines? 1, 2, and 4. So no semicolon. Okay, now steps equals to steps plus 1, right? This is how you cycle through by increasing the number of steps. Okay, now we will have an output instruction, system.out.println. Oops. Robot step number, and then whatever is the steps number. Just so that you can see the progression that it will say the first time robot step number 1, then it'll say robot step number 2, robot step number 3. So in every cycle, you will see that robot takes 1 extra step. And whenever you are done, go ahead and run. And that's the output that you will see at the bottom, which will be robot step 1, robot step 1, robot step 2, and robot step 3. Yes.
So I'll just link that speaking the first step, then it keeps running it through the looping time for a while.
Yes, very good. Yes, that's exactly what this loop is doing. It has a starting point of 1, end point of 3. It just goes from 1 through 3 with an increment of 1. Everybody got it? Okay. Now I want you to change the increment logic to steps plus plus and reduce that to steps plus plus and rerun it. You will get the exact same output. Okay. Now make it plus plus steps. Plus plus steps. Run it, and again you will get the exact same output. So move the plus from the front, from the back, and move it to the front. So this is called pre-increment because you have the plus before, and the first one was post-increment because the plus was after. Okay, we'll have the same output. Now let's do it the 4th way. Steps plus equals to 1. And run it. The 4th way of doing it is more or less used if you have to increment by more than 1. Then the 4th approach is typically used. Because the first 2 approaches are only to increment by 1. The last approach can increment by 1 or more. Okay, so there is nothing like steps plus 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 to increment by 2.
So if step plus equals 1, you want to increment it by 7, change the 1 to the 7.
Yes, so if you want to increment by a 7, you will write steps plus equals to 7. Correct. So to increment by more than 1, you will just simply write steps plus equals to 3, 4, 5, whatever number you want to increment it by. Similarly, if you are coming backwards, then you will say minus equals to and however many steps you want to come back. So if you want your robot to come back 1 step, you'll be minus equals to 1. Okay, everybody following that? Or you could do steps minus minus, or minus minus steps, or steps equals to step minus 1. Either of the 4 approaches can also be taken for coming back. Everybody understood this? Okay. I want you to copy everything that you coded here. Copy it. Click the plus next to main.java and make it main2.java. And paste it. Whatever you have copied, paste it. What is the first thing that you will change? Yes. Very good. Thank you. So change the class name to main2. Okay, everybody got that change? Now, I want to take you to the second loop in line, which is do while loop. So we will make 2 changes here, and this program will work for do while loop. Change number 1, you will replace, you see that? While steps less than equals to 3, you will replace that with the word do. Because it's a post condition, remember, it's a post condition, and while loop is pre-condition, that's why the condition will go to line number 7. On line 7, you will write while steps are less than equals to 3 semicolon. When you run it, you will get the same output as before. Well, I'll explain this code to you once everybody's done running it. Once everyone get to run it, then we will look at the explanation of this code. And you will get the same output, robot, step 1, 2, and 3. Everybody got it? No? You have an error? Oh, you need to replace the word while with the word do. So get rid of whole thing, even the condition. Just put do. Starting point. Very good. You put a semicolon at the end of that line. You have an extra curly brace with this back. So all we did was we moved the while to the bottom, put a semicolon, and replaced the previous while with the word do. Yes. Again? Oh yeah. Okay, now let's go through the explanation of this. You still coding? Oh, okay. So we are starting with step number equals to 1. Are we checking the value of steps on line number 4? No, we just have the word do. That means don't check, assume that it is correct. Go into the body of the loop and first display that this is robot step number 1. Okay, so you start with steps equals to 1. You do not even check the condition. You right away say robot step number 1. What do you do on line number 5? You simply display it, right? What do you do on line number 6? you add the steps by 1 and you make the steps equals to 2 in the first cycle. Now you check the condition on line 7. So this is the first time you're checking. So when you're checking the condition, what is the value of steps? 2. Did you check when the steps was 1? No. That's why I said do while is faster, because do while runs 1 less cycle. It doesn't check the first time. That's it. That's the only difference. It starts checking from the second value. So overall, it checks 1 less time. That's all it does. You can go downstairs to the basement. Okay. Yes.
That's wrong. The computer will still assume that it's right.
Yes, very good statement, Sadiq. If you start, let's say, with the value 100, even though it doesn't matches the condition on line number 7, the loop will still run because you're not checking the condition till the end. Okay? So do while still runs even if the condition is false. Okay. Everybody okay here? Okay, let's copy this. Copy this. Open the next tab. main3.java. And paste it. Everything you copied, paste it over. And change the class name to main3. You okay, Naya? Okay. Everybody else with me? Have the main3 up there. Change the class name. Now we will move to the for loop, the most condensed loop. So this is what for loop does. I want you to first of all delete the word do. Delete the semicolon and the while. So please, everybody, make sure that this is how your code looks like for now. I deleted the word do, and I deleted the while condition. Everybody with me? Okay. Now, where it says int steps equals to 1, on that line, add the word for, parentheses. Before int steps equals to 1, add for, parentheses. After the semicolon, let's put the condition as long as steps is less than equals to 3. And steps plus plus, because we are incrementing steps by 1. So put all 3 things in the same place. Don't run it yet. Even when you're done putting all 3 things in the same place. So we started 1. Some people like this to be spread out, so it's easy for them to read. That's fine. You can add those extra spaces, which are called white spaces. It doesn't matter. And some people make this mistake of putting a semicolon after a plus plus. There is no semicolon after a plus plus. So here, semicolon is a separator between the first and the second instruction and second and a third instruction, but no semicolon after the third one. That's part of the syntax. Okay. Now, one statement needs to go away. Which statement? Yes, because you're already writing that on line 3, so there's no point of writing that here. Now run it. Now when you run the program, you get to see the exact same output as before, which is robot step number 1, 2, and 3. Okay? Oh, there's no steps. That's too bad. Make sure you say steps, and steps. Everybody got this? Yes? Okay. Now, if I want my robot to go 10 steps, what change will I make? Yes? What should I make? 3 should be 10. Run it, and you should see step 1, step 2, step 3, step 4, like that. All the way through, 1 through 10. Got it, everybody? Okay, let's copy this. Let's copy this and start a new tab called main4.java and paste it. Now what I want my robot to do is to come backwards. Okay, I want my robot to come backwards. So let's say my robot has moved 10 tiles. Now I want the robot to be starting where? On the 10th tile, right? So where is my current loop starting? At 1. So first change that to a 10. No. Oh, so we're starting at 10. First, we will reverse the condition. Because right now, what does the condition say? Steps should be less than equals to 10. So if I leave it like this, the loop will only run once. I want the loop to come back, right? So what is my, when I'm coming back, I'm at tile number 10. So what should be the position for my first tile? 1. So I need to come to tile number 1. And I need to reverse the condition. As long as the step count is greater than or equals to 1, I want you to keep coming backwards. Keep coming backwards. Okay? Assalamu alaikum. So the robot is currently standing on tile number 10. Now the robot needs to come to tile number 9. So it needs to come backwards. So use minus minus so that it comes backwards. Okay? So one of you could sit there next to Mustafa. Another one of you could sit next to Abdul Rahim. Not that far. Okay, that's not working. So now when you run it, run this code, you will see that robot starts at step 10, then comes to 9, then 8, then 7, all the way back to step 1. Everybody got it? Okay. Okay. Now let's assume that my robot in each step actually moves 2 tiles. What is my robot doing in every step it is moving? How many tiles? 2. So I need to come back 2 steps. So I will change line number 3 to minus equals to 2. So now my robot jumps from 10 to 8, 8 to 6, 6 to 4, 4 to 2. And then what happens? When it hits 0, it stops. So last tile it visits is 2. Then when it moves to tile 0, it ends. So you can control the forward movement and you can control the back movement. Similarly, if you want your object to be placed on coordinates, so what you do is, you, instead of saying step number this, you now say, okay, robot, move to this coordinate. So the robot has to make sure that it keeps moving till it achieves that coordinate. In the movement of the robot, do you have Z coordinate? Your robot? You do have Z? It goes three-dimensional, climbing the wall.
Oh, we have the elevator, the arm goes up.
Yeah, elevator arm goes up, but I'm saying like the
Oh, the
movement.
base,
The
no.
base. No, it only goes X and Y in terms of movement. But the arm, of course, has a different kind of a movement, right? Yes. Okay. So going back to the PowerPoint. Everybody understand this? Let me take out the bullet points. So what will this program do? Let's ask this question. What will it do? Yes.
Driving move 1 to 5 feet over.
Very good. So the first time the loop runs, it will display driving moved 1 feet forward. Next cycle, it will be driving moved 2 feet forward. Third cycle, 3 feet forward. Nava, what will be the last value it will display? 5, because it is less than or equals to. Okay? Yusuf, what will be the last value it will display now? 4, very good, because I said less than 5. So 5 is a termination point. Okay? What feet values will it display now? Abdurrahim. That's it. It'll display 1, it'll display 3, and 5 will be a terminating point. Correct, because it is jumping by 2. So it is jumping 1 feet. So probably it's a jumping robot. Jumps a foot in every step. Okay? Okay. Ashath, can you please explain this code for us? Can you read from where you are? Okay.
And then it will be reduced by 0.5 after that.
Okay, very good. So this is like a robot coming backwards. It's like the more battery you use, the battery is coming backwards. You're starting at the battery level at 12.5. So your starting battery level is 12.5. Is 12.5 more than 10? Yes. So it goes and says current battery level is 12.5 volts. Then it reduces the battery level by what amount? So what will be the next value? 12. It goes back up. Is 12 more than 10? Yes, so it displays 12. Then it reduces it to 11.5. Then 11. Then 10.5. When it gets reduced to a 10, will it still work? No, because it has to be higher than 10. So it'll only work as long as it doesn't reach 10. Everybody following? Okay. Something very similar to this happens on your phones. That when you reach certain percentage on your phones, the icon for the battery changes. Maybe let's say on an iPhone, as soon as you hit 20%, it changes to a red color. Because you have now met that threshold. Okay? Okay, now let me remove the bullet points here. Okay. Alina, can you explain this loop?
The amount of this like amount of not exceeding the amount of maximum lift, which is 3, then it will print lift amount and how many lifts that actually occurred. And once it hits 3, then it's going to stop.
Very good. So our starting value for the lifts is 0. First time the loop runs, what value will be displayed? 0. Because we are incrementing after displaying. So it starts at 0. Then it increments it to what value? Abdul Rahman? 1. Then is 1 less than 3? Yes, so it goes back and says lifting arm count is 1. Then it makes it a 2. Is 2 less than 3? Yes. It goes back and says lifting arm count is 2. And then it makes it a 3. Is 3 less than max lifts? No. So it terminates. So the values that are displayed are 0, 1, and 2. Okay, everybody good with that? Okay. So the examples that we did here are, in the first example, we are making the robot go forward with while loop. Then we made it go forward with a do while loop. Then we made it go forward with a for loop. And then we made it come backwards with a. Okay. Now, let's go to the next one. We will now do an event-based loops that we have talked about earlier with while and do while. So we'll call this one main5.java. Public class main5. So let's build this from scratch. So public class main5. Now, what do you do for main to show up? What is the keyboard shortcut? Oh, sorry. Control space bar, and then you type letter M, and then you double click on main snippet. So control space bar, M, main snippet. Okay. Boolean. Button pressed equals to false. Again, who can tell me what is an event control loop, as we discussed earlier today? And what is the difference between count versus event?
You have to know how many times it's going to go. Then count would be like it's based on a certain amount of times it has to.
So count control is, you know, the number of times the loop will run. And for event control, as long as the condition is true, it keeps looping. There is no count to it. As soon as the condition becomes false, it terminates. For example, I have a Boolean variable button pressed set to false. That means as long as I do not press the button, it should keep looping. That's what it is. Okay. So I have a stop robot button. If the stop robot button is not pressed, the robot should keep going. Okay. So integer check count equals to 0. I purposely made a mistake because that was one of the mistakes in the quiz. What am I missing? Equals. That was one of the mistakes that was made on the quiz, that people forgot the operator. The other mistake I found in the quiz was I asked the variable, I gave you the name of the variable, and I said I want this variable to be equals to this. But what I got was a data type equals to a value. Variable is a must. You have to give it a name. Okay. What is this operator? And what is this operator? Or what is this operator? Not. Okay. What does not do? Asha.
On, boolean variable is boolean, false equals variable is true.
Okay, so if I say not false, that means it's true. Exactly. Okay. Just like when you guys hear your parents, don't do it. So you put a not next to it and you still do it. No? There's a Boolean variable embedded. Yeah, okay. So while not button pressed, while not button pressed, that means as long as that condition is true, as long as the button is not pressed. That's how you will read it. As long as the button is not pressed. So system.out.println waiting for button press. Attempt check count. So what I'm doing here is, first time I'm in the loop, I'm displaying, okay, what is the check number that I'm reporting? So this is check number 0. Right now, I am at count number 0. And I'm waiting for a button to be pressed. So since I've already reported on the current value, so I want the check count to now go up by 1. Abdul Rahman, you want me to increase the fonts? You good? Okay, you're squinting your eyes a lot, so that's good. Okay, if I run it like this, what will happen? Infinite loop. Why? I'm making an increment big, but I'm never changing the button press to a true. So it always means not false, which is always true. So if you do not change the event loops condition and always keep it true, you will create an infinite loop. In cases where I have to constantly read the sensors, you would want to have an infinite loop unless certain condition occurs. And then you stop that infinite loop. So that's where the multi-threading comes in. But for now, in a single thread application, you do not want to have an infinite loop. So that's why we want to do this. I will wait for the user to press the stop button. I'm going to wait for the user 3 times. So this is more or less like an autonomous code. My robot starts, and my robot is now waiting. I could set a timer there. You guys didn't learn about timers yet. That's done through threads. So I could put a timer here, and I said, okay, I'm going to wait for 3 seconds or 5 seconds. If the user does not presses the button, I will press it for the user. Everybody following that? Okay, but we're doing it through check count. So if the check count, if the check count reaches 3, then what I'll do is I will make my button pressed to true. And what is not true? False. So when it goes back and it see a not button press, since button pressed is true, what is not true? False, and it terminates the loop. Okay? Now, I'm not done yet. Well, I'll let everybody write this code. And let me know if you understand this code. Did everybody understand this code? Okay. Now what I want to do is I want to go outside of my while loop. Now this is where people make mistakes. What do you think is the most commonly made mistake at this point? Creating a new line in the wrong place, right? Okay, to avoid that, I'll always put these comments. Closing if. Closing while loop. Closing main. Closing class. Now, when I put these comments, I know exactly where I am. Who is that curly brace closing? I'll know right away just because I put comments next to all closings. So if I have too many curly braces and you are in the beginner coding phase, so all the beginner coders always get confused between if they see too many curly braces. Okay, everybody with me so far? Okay, this is where I will display system.out.println, println, button pressed, starting operation. Okay, go ahead and run it. Yusuf, I'm pretty sure I didn't do anything funny. Are you showing him something else besides class? And what is so funny on your screen then? Nothing? Okay. Don't distract yourself or others. Okay? Waiting for button press attempt number 0, then waiting for button press attempt number 1, then waiting for button press attempt number 2, and after that, the code steps forward and stops the loop itself. Yes. Oh, S. Oh, your code is a syntax error. Because now you put it in an infinite. What was happening in your case was you set the check interval from 8 instead of 0, implementing the check count by 1. Since it was a case, it was never reaching 3. Okay. Everybody good? Okay. So after the first milestone, some people were eliminated, so they will not be with us in this classroom moving forward. They will be doing other tasks. And you will have your second milestone next week. So whatever we complete this week and whatever we have completed in the past, that will be the basis for the second milestone next week, Tuesday. Okay. Yes. There will be milestones till the last week. So we have 4 more weeks. Okay, now let's move on to our next example. Main6.java. Our next example is more or less based on what we call a nested loop. A nested loop, if you want to understand the nested loop, one of the best ways to understand the nested loop is on that wall. Your analog clock, which has 3 kinds of hands, right? Second hand, minute hand, and hours hand. So nested loops work exactly like that. Second hand has to complete how many cycles for the minute hand to go up by 1? 60. Once the minute hand becomes the next number, does the second hand get reset? Right. And minute hand has to complete how many cycles for the hour hand to be displaced by 1? 60. So once an hour hand that gets displaced by 1, minute hand is set back to 0. And within that minute hand, the second hand gets set back to 0. Nested loop works the same way, where the second hand is the innermost. The level up is minute. The level up is hour. So here, in this example, you have the outer loop. Look at the very first one. Repeat is the variable that is controlling the outer loop. What is the starting point for repeat? 1. What is the ending point?
2,
3. And what's the increment by? 1. So that is quite evident. I'm going to run for how many times? 3 times. First time will be 1, second time will be 2, third time will be 3. So keep that in mind. Come down to the third line where you have a variable step. Muhammad, what is the starting value for step here? On third line. 1. What is the ending value for step, Yusuf? 2. And Abdul Rahman, what's the increment value for step? 1. So how many times it will loop, Abdul Rahim? The second one, 2 times. Okay. So the outer one loops for how many times, Ashraf? 3. Inner loop runs for how many times, Sadiq? 2. What is the product of 3 and 2, Mustafa? 6. And why am I taking a product? Okay. If I ask you, in each hour, how many times does the second hand moves? What will your answer be? 3,600 times. How did you do that? In every minute, second hand moves 60 times, and there are 60 minutes in an hour. So you multiplied 60 by 60, and you got 3,600. So that's why in every occurrence of the outer loop here, inner loop moves 2 times. And how many occurrences of outer loop are there? 3. You multiply the total number of occurrences of the outer loop. You multiply that by the total occurrences of the inner loop. And the product of the 2 will tell you how many times the inner loop will run. Are we following that? Okay. Yes. No, inner loop will run total of 6 times. Correct. Inner loop will run twice for every outer loop occurrence. So when outer loop is 1, inner loop run twice. When outer loop is 2, inner loop run twice. When outer loop is 3, inner loop run twice. Yes, Mohammed. Oh, you're just stretching. Okay. So the total number of times the loop will run will be 6. How many times will this loop run now? 8. Because the outer loop runs for 4 times. The inner loop still runs twice for every outer loop occurrence. Okay. How many times will this loop run now? 16. So every outer loop cycle, inner loop runs for 4 times. So since there are 4 outer loop cycles, 4 times 4 is 16. Okay, now how many times the inner loop runs? 24. Okay. Now how many times? 18. Now how many times?
Oh,
18. 18. How many times the outer loop runs? First look at it. It'll be 1, then it'll be 3, then it'll be 5. Because I said less than equals to 5, so 5 is included. For every time outer loop runs, inner loop runs for how many times? 6. 3 times 6 is 18. Okay? So outer loop can have its occurrences at its own interval. Inner loop can have its occurrences at its own interval. It's pretty much like a clock. The hour hand moves how many times total in a day? 24, right? But in each cycle, 12, because the way the clocks are based, the analog clocks are 12 cycles, because it is half-day cycle clock, right? So it's 12 cycles, and each cycle has 60-minute cycles. So minute has its own cycle, hour has its own cycle. The day has its own cycle. What is the cycle of the day? The whole clock needs to complete all its cycles twice in a day. Right? So to get to how many times a second hand moves in a day, you will do 2 times 12 times 60 times 60. That's how many times a second cycle moves in a day. And in a month, you'll multiply that by the number of days in a month. In a year, you'll multiply that by the number of days in a year. And in somebody's lifespan, you'll multiply that by the number of years that they have lived. Okay, so going back to this. Now that I am inside my inner loop, let me change it back to the way it was before. This was 3 and this was plus plus, correct? Okay. Now repeat is 1. Let's go one step at a time. Repeat is 1. Step is 1. If step is 1, what should you say? Drive forward. And what is the other possible value for step? 2, because step only has here. Oh, let me change it back to, sorry, the way it was 2. Okay, step only has 2 possibilities, 1 and 2. So if step is 1, it moves forward. If step is 2, what does it do? Turn right. Okay, now, so in my first cycle, my robot moves forward, then turn right. Then it goes back and repeat becomes 2. When repeat becomes 2, when it comes back into the inner loop, it restarts from step equals 1. So this is what basically the movement of my robot is. Forward, right. Forward, right. Forward, right, stop. Everybody see that? Okay, this is the first repeat cycle. This is the second repeat cycle. This is the third repeat cycle. Repeat cycle 1, repeat cycle 2, repeat cycle 3. So if I am creating an object and I'm animating it, let's say in Roblox, and the object is supposed to move in a pattern that I generate, I'll be writing something similar. That the number of turns it has to make and the directions it has to follow. So anytime we do animations, how do you animate an object? You take an object, then you build a path, and then you make the object run on the path. And that's how animations are done. So in a cartoon, when you see certain objects moving faster than the other objects, because I'm making them change frames quicker than the others, so it appears to your eye that this is faster than the others. That's why when you look at the World War I footages, looks like the whole world is moving at a faster pace because the frame rate was slower. So we had to change, we had less frames to work with. So it appeared like people were moving quicker. And even now, when you animate, that's exactly what you do. You put a timer and you change the frames quicker, so it looks like the object is moving faster. So in the good old days, when they were starting to make Disney movies, what they were doing, they were drawing it on the paper, and they're moving the paper quicker to make you appear on the screen as if it was running. And if they move it slower, it made it appear like it's walking. Same object, same pictures, changing the frame rates. That's about it, okay? So, everybody okay with that? Okay. How about we code this one? Public class main6 main. For integer, row equals to 1. Row should be less than equals to 3. Row plus plus. Let me label them. So this is my outer loop. This is my main method. And this is my main6 class. Just so that you know that these are the different closing ones. So how many times this loop will run? 3 times, right? And let's represent that my robot is supposed to go through 3 rows. So I'm starting with row number 1. Then I'm going row number 2. Then I'm going row number 3. So my robot goes and completes the first row. Comes back, completes the second row. Comes back, completes the third row. Okay. So this is scanning rows. It can be done with 1 loop. But if my robot also needs to scan cells, then I have cell number 1, cell number 2, cell number 3. Now I need nested loops. So first, my robot will need to know that I want you to be in tile number row 1, tile 1. Then I want you to move to row 1, tile 2. Then row 1, tile 3. Then row 2, tile 1, row 2, tile 2, row 2, tile 3. Then likewise complete the remaining tiles. So this is my grid. So if the robot is scanning, that's exactly how it will scan. So anytime you give a task to a robot, you will notice that you need to have your plane set up. If the robot needs to do cooking, have you ever seen a cooking arm where a robot does all the cooking with precision for you? things have to be laid out. The prep has to be done correctly. So robot needs to be told row number 1, column number 5, that's where the pan is. So it goes out, it scans it, grabs it, put it down. But if you change the object, robot gets confused, and instead of a pan, if you put salt there, we'll go for a salt and we'll probably drop it on the stove and burn the plastic. It wouldn't know. So they have to be prepped exactly the same. It needs to know, I need you to go to drawer number 3, and I want you to go to coordinate so and so. That's where the knife is. You take the knife out, you go to coordinate so and so and grab the carrot. And now start chopping. So it needs to know where the chopping board is by coordinate. So it puts it there and goes through the chopping process. It needs to then be told the precision, how precise you want these to be. So it just makes sure that all strokes are going the same way as it's moving through the process. So when it goes up, it comes down at a certain angle. Goes up, comes down, same angle. This is all what? The engineering, this is all what? Trigonometry, where you apply your trigonometric functions in combination with your geometry, which talks about the planes. Okay, now I need my robot to move columns. And this is where my inner loop is closed. So that's why I'm putting my labels, to avoid any kind of confusion with the closers. Okay, now comes my output. System.out.println scanning cell at row number this and column number this. Scanning cell at row number this and column number this. So when you run this example, it will display you row 1, row 1, column 2, this, and it goes like that. And you may have to scroll up because it gives you 9 outputs for you to see all outputs. And create a new class called main7.java. Public class main7. So this will be like a battery check task. We'll not have entire code here, but this is just a code snippet. We need to run 2 tasks, numbered 1 and 2. I want you to write a for loop that will do that. Variable name is task. So we need to run 2 tasks in a loop, starting at 1, ending at 2. So for integer task equals to 1, task should be less than equals to 2, task plus plus. So that allows me to run 2 tasks under the variable name task. And since the values are 1 and 2, I used integer as a data type. Okay, now I'll display an output. System.out.println. Starting task, and then I'll display the task number. Now I want you to write the inner loop. Each task will have 3 steps. So code an inner loop using variable step to run 3 times or thrice, probably. I could use that. Thrice. Mr. Kamani, what will be the output if I run this example exactly the way, just like that?
When starting task 1 and
Very good. Because there's no output in the inner loop, that's why only the outer loop will generate an output. And since the outer loop runs twice, there'll be only 2 sets of outputs. So it's possible that inner loop is only designed to do something, but not produce an output. An outer loop is the only one that's producing the output. Out.println. Now, in the real application, this is where I will have a code which will go and check the battery status. So checking battery before step number this. So it will actually go out and check the battery status. If the battery status is not okay, next line will not run. If the battery status is okay, then it will run the line that will say, okay, system.out.println, executing step number this. It's the same step. So here you see that the same variable is used twice in the output. So we'll start with the task number 1. We'll check the battery before step 1. We'll execute step 1. Then we'll check the status again for step 2. Then we'll execute step 2. Then we'll go and check the battery status before step 3. And then we'll start with task number 2. Each task has 3 steps.